welcome viewers to our YouTube channel and our Facebook page. So wherever you're watching us from, if it's on Facebook, feel free to invite your friends so that they can learn whatever we post on this page with us. Okay, if it's on YouTube, feel free to subscribe so that in the future you are able to view more of this content. So as you can see on the board, we are looking at linear programming. Okay, and I believe this is our first lesson. Okay, this is our first lesson, which we are looking at the introduction. Okay, so this is our first lesson. So we have to understand something. What is linear programming? Okay, what is linear programming? So we are saying linear programming is used to solve maximization and minimization problems of linear functions subject to constraints. So these constraints can be inequalities or equalities. Okay, so this is one branch of mathematics that is very, very important because it is used in what? Businesses. It's also used in economics. It's also used in what? Manufacturing fields by engineers. Okay, so when you talk of businessmen and women, they normally apply the concept of linear programming. That is, if they want to maximize their profit, okay, and they want to minimize their cost, where they normally apply this principle. So we have said these constraints, they can be inequalities or equalities. So this takes us now to our point of discussion. We are going to look at inequalities. Okay, so it's very important that you understand the concept of linear programming, and it's widely used in day-to-day interactions. Like I've said, that it's used by businessmen and women. It's also used in economics. It's also used by engineers. Very, very important points to understand. Okay, now we are saying this one, it also involves inequalities. Okay, so what are these inequalities? So an inequality, in simple terms, is just saying this is a mathematical statement that uses symbols. That is what we call an inequality. A mathematical statement that uses statements. Okay, so what do I mean? This mathematical statement that uses symbols, we are talking of symbols such as, so we are saying inequalities uses symbols such as, we have this symbol, we also have this symbol, we also have this symbol, and we also have this symbol. Okay, so we are saying inequalities, this is a mathematical statement that uses mathematical symbols. What type of symbols are we talking about? We are talking about this symbol, which means less than. We are also talking about this symbol, which means greater than. And we are also talking about this symbol, which means less or equal to. We are also talking about this symbol, which means greater or equal to. Okay, so it's very important that we understand these symbols. Okay, so we have said inequalities or an inequality. This is a mathematical statement that uses symbols such as the less than, greater than, the less than or equal to, the greater than or equal to. So when you see this on these symbols, they simply mean that it's also part of the solution set. It's equal to. Okay, so we are saying this symbol means less than. Okay, then this one means less than or equal to. Okay, then this symbol, we are saying this symbol means greater than. Then this symbol means greater than greater than or equal to. Okay, so it's very important that you understand these symbols because they are the ones that you are going to use under inequalities. Okay. All right, so let's take a note of these symbols. Okay, the inequality symbols. This symbol greater than or less than or equal to. Okay, in fact, allow me to erase this. Say less than or equal to. This is greater than or equal to. So the reason why I'm emphasizing on these symbols is that, remember, these symbols are presenting inequalities. Okay, they are presenting inequalities. They are giving you certain conditions on the left hand side and the right hand side. So it's very important that you understand how to use them. Okay, so you find that in the past papers, mathematics exam past papers, okay, either in paper 1 or in paper 2, you may find that they ask you to describe certain inequalities that have been plotted on the Cartesian plane. Okay, so it's very important that you understand when we talk of the inequality symbols such as less than or equal to, also greater or equal to, these that are having equal to, okay, these two inequalities, the type of the line that you draw, you call it a solid line. When you draw something like this, okay, this is called a solid line. Okay, why are we calling it a solid line? Because it means that even the number where you are is part of the solution set, because you are saying is less or equal to or is greater or equal to. For example, if you are given something like this, x greater or equal to 2, so this means the solution, okay, the solution set will also include the 2. It's part of the solution set because it's equal to itself. Okay, so when you are plotting this type of an inequality on the Cartesian plane, you have to draw this type of a line. Okay, very important for you to understand this. Also, in the case if you have x less or equal to 2, it means that even this 2 is part of the solution set. We are looking at numbers that are less or equal to 2. So you start from, you say you have 2, or numbers that are less or equal to 2. Okay, we start from 2 is part of the solution set. 1 is less, 0, -1, -2, and so on and so forth. This is what it means. So when you are plotting this, it means that even this 2 is part of the solution set. So you are going to draw this type of the line, a solid line. Now, when we talk of the other symbols, like this one, which is just having less than or greater than, these two symbols, when you are plotting them on the graph, they are going to give you a line that is broken like this. Okay, they'll give you a broken line. This is what we call a broken line. Okay, so why this broken line? It's showing that, for instance, I'll give examples on this. I was saying x greater than 2. Okay, when I say x greater than 2, I'm looking at numbers that are greater than 2. So these numbers will start from where? 3, 4, excuse me, 5, 6, and so on and so forth. This is the solution set. Okay, meaning that these numbers starting from 3 going up, they are greater than what? 2. So when I'm plotting this on the Cartesian plane, okay, like for instance, this is my Cartesian plane. When I'm plotting them, this is the origin, this is the x-axis, and this is the y-axis. Okay, so this in the y-axis, we assume that 2 is here. When I want to plot this, I've said it because it's just saying greater. Okay, it's not equal to 2 itself. Where I've said 2 is not part of the solution set, so I'm going to draw a broken line like this. Okay, this is a broken line. Then we say x equal to 2. Okay, I hope you understand this. So we draw this broken line if it's not equal to the solution set. Okay, this is what we mean. So you have to understand between the two types of lines, a solid line and a broken line. All right, so we have understood now those symbols, okay, the type of lines that we are supposed to come up with. So let's look at plotting inequalities, okay, plotting inequalities. Okay, so first, before we look at examples, we have said the symbol, less or equal to or greater or equal to, the symbol less or equal to or greater or equal to are drawn using the solid line. Okay, so this is very important for you to understand. The symbol less or equal to or greater or equal to are drawn using the what? The solid line, because of the equal to. Okay, because of the equal to. And I've said the equal to simply means it's also part of the solution what set, just like the previous examples I was giving you. Okay, so this is our first point. Then the symbol less than or greater than, these symbols, these two symbols, the one that don't have the equal to, you can see there is no this equal to signs here. So these are drawn using the broken what lines. So I have said these are drawn using the broken lines. All right, so having understood the type of lines, okay, that we can use when we are plotting inequalities, okay, we have talked of the solid line, which looks like this. This is a solid line. We have also talked of the broken line, which looks like this. Okay, so I'm emphasizing on these two types of lines so that you people understand. Okay, so this is the broken line. This is the broken line, and this broken line, we come up with them once we have the inequality symbol, which is less than or greater than. Okay, then this is the solid line. Okay, this is the solid line, and the solid line, we come up with it when we have inequality signs such as less or equal to or greater or equal to. So that's when we draw this type of what lines. So if you have understood this, let's now look at the Cartesian plane. I'm trying by everything possible to make this lesson easy for you to understand. Okay, so let's look at the XY plane, which we call the Cartesian plane. So when we talk about the Cartesian plane, remember we are talking about plotting inequalities. Okay, so you can't just plot inequalities minus the Cartesian plane, which is the XY plane. So what is this XY plane? The Cartesian plane, this is the graph, okay, which consists of the x-axis and the y-axis, and it consists of 4 quadrants. Okay, so what do I mean? If you have something like this, okay, you have something like this. This is what we call the Cartesian plane. Okay, so this horizontal line is called the x-axis. Then this vertical line is called the y-axis. So here we have the origin. Okay, the origin, this is the starting point when going to the x-axis and the y-axis. So on top of the y-axis here, we have positive values, we have positive numbers. You have 1, 2, 3, 4, depending with how the question is. When we come down here, we are still in the y-axis, we have negative values. Then this is the x-axis. On this side we have positive values, on this side we have negative what values. This is something that you must understand. Okay, now let's look at some of the properties that are on this what Cartesian plane. There's some properties that you must understand. I've said this is the x-axis So the same x-axis, this is the line y equal to what? 0. The same axis, this one, this is the line y equal to 0. Okay? Then in the y-axis, here, the y-axis, this is the line x equal to what? 0. I hope you have gotten this principle. Okay, this is one property of the Cartesian plane that you must understand. Okay, so I've said the Cartesian plane consists of the x-axis and the y-axis, and it has 4 quadrants. Okay, 1, 2, 3, 4. So when we go deep, I find that these quadrants mean something else. Now we are saying in the x-axis, this is the line y equal to 0. In the y-axis, this is the line x equal to what? 0. It's important under linear programming to understand this property of the Cartesian plane, okay? Because they can ask you to say, plot the point x equal to what? 0. Or, sorry, since it's linear program, it's inequality, you say, plot the point x greater than 0. Okay, so don't want you to be confused. Where is x equal to 0? So this is the line x equal to 0. This is the line y equal to what? 0. So let's look at another property, okay? Okay, so we have looked at some of the properties, okay? Where we said y equal to 0. This is the line y equal to 0. Okay, sorry. This is the line y equal to 0. This one, y equal to 0. Then x equal to 0. This is the line x equal to 0. This one, okay? So now let's look at another property which is on this Cartesian plane. Okay, what property is that? This is the property where we have y equal to x, okay, or x equal to y. So this line, it passes here from the origin like this. This is the line y equal to what? X. Okay, so you have to know this. You have to know this. Y equal to x. Okay, so this line, the way it's come up or the way it's drawn, this is, we understand that this is the straight line. So the points, they were like this. You are starting from the origin, so it's 0, 0. Okay, for instance, you have 1, 1, or you have 6, 6. This is the line that you have come up with, a straight line. Okay, so now let's look at some of the examples now. Okay, how we can shade. Okay, how we can shade certain inequalities. Okay, all right, so let's now look at the first example. Okay, so this is our example 1. This is our example 1. Okay, so this example 1 is saying, show the solution by shading the unwanted region. Show the solution by shading the unwanted region. So I just want to talk about certain points. If you are dealing with the linear equations, okay, we understand that first we have to solve them, then we draw the straight lines. Okay, it's just the same. If you are dealing with linear inequations or linear inequalities, you are also supposed to solve them. Okay, first you change them into equations, then you solve them, and you identify the region or the condition which is suitable according to your calculations. So show the solution by shading the unwanted region. We have the first one, x greater or equal to 0. The second one, y is less or equal to 0. The third one, y is greater than x. The fourth one, x plus 3 is greater than 6. Okay, so how can we show these linear inequalities on the Cartesian plane? Okay, remember they have said you have to shade the unwanted region. Very important for us to understand this. Okay, so I'm erasing here, rubbing here so that I create more space. So if you remember, we said the Cartesian plane, okay, will look like this. Going to have something like this. Okay, going to have something like this. So this is our x-axis, this is our y-axis, this is the origin. Okay, so based on the inequalities that I'm being given here, I'll just say in the x-axis I'll come up with my own maximum points. Okay, where I'll say 1, 2, 3, 4, 5. Okay, it's fine. Then here y-axis 1, 2, 3, 4, 5. So I can even put maybe -1 and -1 there, it's fine. Okay, so we start with the first one. As you can see, this is x greater or equal to what? 0. X greater or equal to 0. So we have to understand that according to the features of the Cartesian plane, or the features of the graph, we said that the line x equal to 0. Okay, so I'm changing it now into an equation. The line x equal to 0. This is the y-axis, which is x equal to what? 0. Okay, now they are saying greater or equal to. Okay, greater or equal to. So if this is the line x equal to 0, okay, it means that going this side, these numbers, they are greater or equal to what? To 0. Okay, from here going this side, this side, the numbers that are this side, they are greater or equal to 0. So in short, I'm saying this is the wanted what? Region. Okay, now remember what the instruction said. They said shade the unwanted what? Region. In other words, what I'm saying is we shade the opposite. Okay, so the wanted region is what? This side. Okay, this is the wanted region, greater or equal to 0. So we are going to shade the opposite. And which one will be our opposite? We are going to shade this side. Okay, this is the opposite. We even say this is x equal to what? 0. This is the line x equal to 0. We have shaded the opposite. So I'm sure I've understood this one. Then we come to the second one. Okay, y less or equal to what? 0. So according to what you have said, this is the line, this one down here, the x-axis. This is the line y equal to what? 0. Now, according to the conditions that we have been given, we are saying y less or equal to 0. So when you look at this Cartesian plane, you find that when you come down here, okay, the values which are coming down here, they are less or equal to what? 0. Okay, they are less or equal to 0. So this is the wanted region. Okay, now which one is the unwanted region? I've said we shade the opposite, the unwanted. So the unwanted region is this. Okay, we shade this. This is the region that we are going to shade. We have said this is y equal to what? 0. Now when you talk, alright, so I'm saying when you look at this, x is greater or equal to. So when you look at this line, you can see that it's a solid what? Line. Because when we are drawing the Cartesian plane, in the y-axis, we can't draw broken lines like this, no. So no wonder this one, you always have a solid line inclusive of this line, okay? Including this line here. So no wonder we're able to see that. So even this one, we are done. We come to this one. Y greater than what? X. So if you recall what I said earlier on, I said the line y equal to x, it passes here on the middle, okay? It passes on the middle. Now before we draw, we have to look at the inequality that you have, the sign, okay, the symbol. So this symbol is just saying greater. There's nothing like equal to. So I understand that you are going to come up with a broken line, okay? Take note of this. Very important. You are going to come up with a broken line like this. You're going to come up with a broken line, okay? So this is our broken line. Okay, so as I've said here, we will draw the broken what? Lines. Why are we making the broken lines on this line y equal to x. It's because when you look at this inequality sign that is used, this symbol, it's just greater, okay? It's not equal to. We said broken lines, these are drawn when you just have this symbol less than or greater than, because it's not equal to, okay? So this is why I've drawn the broken line. Now, where are we going to shade? They want us to shade the unwanted region, okay? So for this line which passes here, you must understand that the upper region, this is the upper region and this is the lower region. So the upper region is greater, okay? I'll repeat. The upper region is greater, then the lower region is less, okay? So they want you to shade the unwanted region. So let's look at the condition. Y greater than x. Y greater than x. So this is the wanted region, okay? It's the one that is satisfying this condition. Y greater than x. This upper region is greater. Okay? Now I'm saying we shade the opposite, the unwanted what? Region. So the unwanted region, we understand where is it going to be? Okay, so I'm going to shade here. Okay? This is the opposite, the unwanted region, okay? Even say y equal to what? X. So I hope you are following. I hope you are following. So we have answered this. We now come to this one, okay? Which is saying x plus 3 greater than 6. So remember what I said that first? This inequality, the way it's being given, first change this into the equation. So to change this into the equation, it's going to be like this. It's going to be like this. X plus 3 is equal to 6. Okay. X plus 3 is equal to 6. So here, positive 3 and 6 are like terms, okay? So I want to solve for x. So I'm going to say x is equal to 6 minus 3. X is equal to 6 minus 3. So once we do that, x is equal to 6 minus 3. We are going to get what? A 3. Okay? We are going to get a 3. So let's identify the line where x is equal to 3. Okay? This is the line, the point. This is the point. Because this is the x-axis. So this is the point where x is equal to what? To 3. Now I want to shade the unwanted region. So we have to draw a line. What type of a line are we going to draw? Let's look at our inequality that we have our symbol. Okay? This is our symbol. It's just saying greater. So this is where our point is. X equal to 3. It's there. Okay? So what type of a line are we going to draw? Is it a broken line or a solid what? Line. So what you tell us what type of the line we are going to draw is the inequality sign. Okay? This sign is just saying greater, okay? It's not equal to. So if it's just greater, we understand that we are going to come up with a broken what? Line. Because we have said that. So here we come up with a broken line on x equal to 3 on this point. So this is our broken line. Make sure you get a ruler. You place it on this point where x is equal to 3. Okay, so this is our line x equal to 3. Now they are saying greater, okay? So we have solved this and it's x greater than what? 3. Okay, x greater than 3. So we want to shade the unwanted region. X greater than 3 is from this 3 going this side, meaning we start from 4 numbers that are greater than 3. 4, 5, 6, 7, just like that. Okay? If it was equal to, I would have started from 3, saying these numbers, 3 is also included. It's part of the solution set. Now it's not. It's just saying x greater than what? 3. So the numbers that are greater than 3, 4, 5 going above. Okay? And that's why I've drawn this broken line, because it's just greater. It's not equal to. So the wanted region is this. Okay, now I want to shade the unwanted region. So the unwanted region, which is the opposite, is coming this side. Okay, so I'm going to shade this side. Okay, so this is the region where x is greater than 3. I even say x is equal to what? 3. So if you have understood what you have learned, all right, viewers, so we have come to the conclusion of the lesson 1. Okay, remember what I've said, this is lesson 1. It's just more like part of the introductions. There are more lessons to come. Okay, so don't forget to comment where I've got, you have seen that you're struggling somewhere. You can comment so that we are able to respond to your comment. And don't forget to subscribe to our YouTube channel, and you also follow our Facebook page. Okay, and keep on inviting your friends. So as you can see on the board, I've written the exercise. You can try to work out or to plot these inequalities, okay, based on what you have learned. So just a quick sum up, we have said linear programming normally deals with what? The maximization and minimization of what? Certain linear functions which are subject to constraints. So these constraints, we call them inequalities or equalities. And we said inequalities, this is a mathematical sentence that uses the symbols such as the less than or equal to, greater than or equal to. Okay, then we have also talked about the type of lines when you are plotting these inequalities on the Cartesian plane. There are certain types of lines that we can use, the broken lines and the solid lines. So take note of those points. The broken lines are drawn when you just have symbols or inequalities such as less than or greater than. We are using the broken lines. Okay, then when it comes to solid lines, we draw them using, if we have inequalities such as greater or equal to, less or equal to, we draw using the solid lines, where we said if we're having this, it means that even the number itself is part of the solution set. Okay, so thank you so much for viewing our content. During your own free time, you can try to work out this exercise. Okay, so see you in the next lesson that will be posted. Bye bye.